Hello, everybody. Welcome back. Mr. Crofton here again. This time we're talking about polygon angle problems. Let's see what exactly that means. All right, so we're looking at interior angles and exterior angles of polygons. A polygon, of course, is just any closed figure with straight sides to it, no curves or anything. First part we're looking at is the interior angles. So I got them marked here in red. These are all interior angles, pretty obviously because they're inside the polygon. Our rule for this, interior angles of a polygon always add to 180 times n minus 2, and in this case, n means the number of sides. Okay? So think about the shapes that you're used to seeing. Triangles, 3 sides, minus 2 gets you 1 times 180. Gets you 180. So that tells you the sum of the angles of a triangle is 180. You can do that for any shape at all. Okay? Exterior angles got a formula that's, believe it or not, even a little easier. Exterior angles are formed when you just continue, basically extend one side of the polygon. There's an exterior angle that's formed at every angle. It's supplementary with the interior angle. And guess what they always add to? 360. Straight up, every single time, no matter what shape it is, add the 360. Awesome. All right, let's use these rules now and try to solve some problems. So we want to find x here, and just like as if it were any shape, I want to figure out what those angles have to add to, okay? And I know there's 1, 2, 3, 4, 5, 6 sides. So I plug it into my formula, 180 times 6 minus 2. 180 times 4 gets me 720 degrees. Awesome. So I know that the sum of all of these angles are 720 because it's a hexagon with 6 sides. So what I do is I make a little equation. 720 is going to be equal to the sum of every single angle. So that's 100 plus 140 plus 110 plus 115 plus 135 plus, of course, x. Then to get x by itself, just like any other equation, I want to get rid of everything else. So I subtract 135, subtract 115, subtract them all on this side, and what you're left with is x by itself. And on the left, if you go through with your calculators, you'll find out that that angle has to be 120 degrees. Okay? Awesome. Pretty easy one. That's because they're interior angles. Now let's check out one with exterior angles. And I notice first thing you might look at is like, okay, there's 1, 2, 3, 4, 5 sides. Guess what the exterior angles add to then? It's always 360. Doesn't matter. You don't even need to count the amount of sides. So I know that 360 is going to be equal to the sum of this and this and this and this and this. Okay? So 60 plus 70 plus y plus 65 plus 40. So I got all those angles in there. Do the same thing. Subtract 40, subtract 65, subtract 70, subtract 60, subtract them all over there. You'll be left with y on its own on the right is equal to 125 degrees. You can always go back and check your answers by plugging it in, seeing if it actually adds to 360 or whatever it's supposed to add to. All right, one more very similar problem. One difference though. I've got interior angles. I know this because no sides are extended. But I've got a 1, 2, 3, 4, 5-sided figure. So do a quick little bit of math. 180 times 5 minus 2. Again, I want to subtract that 2 there. Gets me 180 times 3. Gets me 540. Okay, so the sum of all of these angles is 540 degrees. So do the same thing. The part where it gets a little funky is the fact that you got these x's involved. You got little expressions for each angle. But watch this computer magic. Do the exact same thing. This plus that plus that plus this. Where's the other one? Plus this one. Awesome. I want to add these things all up, and they should still equal 540. Look at how much time I save by doing that. Now, instead of subtracting everything straight over, I need to combine like terms. So I combine the 5x, the 5x, the 3x, the 4x, and the 8x to get a total of, continue our 540 down here, 25x. All right? I add all those things up. My other thing that is called a like term are just the constants, 8, 15, 5, 10, and 2. I add all of those up, and I get 40. Okay? And I want to get x by itself. So to get rid of everything else, I'd subtract 40 over here for a start. It's a good idea. Let's extend. So 500 on the left equals 25x. And to get x by itself, I divide by 25, divide by 25, and I get x equals, what do I get here? 20? 20. Sorry, took me a minute for that one. But there you go. And if they do ask for angles, in this case I didn't, but if they ask for an angle, x is 20, come on up here and plug in 20 for any of these x's and you can find any angle. Everyone's favorite time. Oh, very appropriate too for this video. What do you say when you see an empty bird cage? Empty parrot cage, more specifically. Think, what do you usually call a parrot? Maybe Polly? Polygon? Ah, Polly's gone. Oh, that's so good, so good. All right, on to the next one. Find y. We're going to skip that one. On to this one. Sorry, a little confusion there. We're not going to skip this one. It's good practice. So, I look at it, and again, I diagnose it. I'm looking at a bunch of exterior angles. So, what do they always add to? Always, always, always 360 degrees. So, all of these angles here are going to add to 360. Watch the magic. Wow. Oh. Amazing. Oh, no. I did not just do that. Go. Take every single one of those angles here, and let's move them over a little bit. Give me some room. Awesome. I got all these. I want to add them all together, and I know the sum of all of these angles will get me 360. Do the same thing we usually do. You can combine like terms, or you can subtract them over. I'm going to do this kind of at the same time to save us a little time. Why not? I want to get rid of 59 degrees. I want to get rid of 61 degrees. I want to get rid of 50 degrees. I want to get rid of 35 degrees. Cancel, 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 cancel. I need to subtract all those numbers over here, and I should wind up with 155 equals y plus 2y, right? Because I still have this and this left over. I add y plus 2y, I get 3y equals 155. Divide both sides by 3, and I'm left with y equals 51.66, repeating. And you might right away say, oh no, I did something wrong. Let me put degrees on there. I did something wrong. There's a decimal, and it's not a nice, pretty decimal. That's okay. And not everything always works out to be perfect, so that's all right. My answer is 51.66, and I'm good with it. Cool. All right. Now a good one. I love this problem. No numbers involved whatsoever, but you got to use your brain. I know that from the previous problems, a pentagon adds to 540. I know from, well, my brain, that a quadrilateral, the angles always add to 360. I know a triangle is 180, right? Now, all of these markings here tell me all the angles are the same. So that 540 here gets divided up 5 times equally. So each of these angles are 108, every single one of them, okay? Same thing here now. The 360 gets divided 4 times into 4 angles. So each of these angles have to be 90, okay? By the way, these sums you can all go get from the formula. We know that, not just from your brain. And then the last one, the triangle. 180 divided by 3 gets me 60 for all of these. Okay. Now, I've got all these angles. I want to look at angle A first. That's, angle A is, let's mark it blue here, is this angle here. It's a pretty wide angle. It looks obtuse to me. But notice that we already know the 108 and the 90 right here. What does it look like those three angles make together? If you thought circle, you're right. A circle's 360. So I take 360, I subtract 108, and I subtract 90, and I'm left with my angle A of 162 degrees. Fantastic. Next one, let's get a little trickier here. I want to find B, which is down here, but oh boy, that gets a little tricky. Here's my suggestion. Look at what's going on up here. I know all three of these angles here. And then there's one missing angle right here that's going to form my circle. So I know that, again, my circle is 360. I'm going to subtract 108. I'm going to subtract 90. And I'm going to subtract 60 to see what this angle has to be. And it's going to be 102. Oops. 102. So this angle here is 102. And then something dawns on me. This triangle right here is isosceles. So if that's an isosceles triangle, I know that the angles must add to 180, and these two base angles, angle B and this one here, have to be congruent. So 180 minus the angle of 102 that I know is 78. And guess what? That's got to be split evenly between this and this angle. So divide that by 2, and I wind up with 39 degrees is equal to B. Boom. Oof. Man, I am feeling like a pro. Look at that. This problem started with no numbers. I just marked it up with a ton of numbers. But they're good numbers. All right. Now, this last slide here we're going to do is just working with the formula a bit. The formula of 180 times n minus 2 is a key thing to remember. This first problem says, if the sum of the interior angles of a polygon is 1,800 degrees, how many sides does it have? Well, 1,800 is equal to the sum of the angles, and we said the formula for the sum of the angles is 180 times n minus 2. I'm just working this one basically backwards, okay? And to work it out backwards, I want to get n by itself. I want to first divide by 180. And I might notice that I'm left with, on the right, n minus 2, and on the left, 1,800 divided by 180 gets me 10. I got to solve for n, though, so I add 2 to both sides, and I wind up with n equals 12. Cool. First one down. Next one, sum of the exterior angles of polygons 360 degrees. How many sides does it have? Well, that's a simple answer. I don't know. It could be any, and I mean any polygon, because all polygons, their exterior angles add to 360. Nice. That's a good one. What's the measure of one angle of a regular 20gon? Okay, so here I got to find the sum of the angles. To do 180 times 20 minus 2, okay? Because, right, I want to find one angle, but really, if I find the sum of them, I know I'm pretty close to it. If I do 180 times 18, essentially, it's 3240. And that's a lot of degrees, but I know that is split evenly among the 20 angles. So I divide that by 20, and I get 162 degrees. Awesome. Okay. And notice, this is basically our formula. The sum of the angles divided by the number of sides. This is something we're going to base our next problem off of, which I've labeled as a little tricky, but we can do it. If one angle of a regular polygon is 156 degrees, how many sides does it have? Go back to this one and realize what you did. And you got to do it backwards. 180 times n minus 2 divided by n. That's basically the variation of the formula I just used. And I know that is going to crank out for me 156 degrees. So I got to find n from that. We might recognize a little cross multiplication that we can do. So when you cross multiply 156 times n, I get 156n. Cross multiply down here, and I love multiplying by 1 because it doesn't do anything. 180 times n minus 2 remains kind of untouched there. All right, moving on. I now want to distribute. Boom and boom. 156n equals 180n minus 360. Is 180 times 2, right? And I want to get n by itself, so let's pull this 180n over to the left. And I noticed something that might make you a little uneasy. No one likes a negative, but whatever, we can work with it. We've got negative 24n equals negative 360. Don't forget those negative signs, right? Get n by itself, you divide by negative 24, divide by negative 24, and what I'm left with at the end, n equals 15. So that is a 15-sided polygon, a 15-gon, if you want to be fancy. Good job. See you out there.